Now we are going to take up one more example of a pentagonal lamina having edges. Having edges 25 mm is placed on one of its corners on HP such that the perpendicular bisector of the edge passing through the corner on which the lamina rests is inclined at 30 degrees to HP and 45 degrees to VP. Draw the top and front views. So this is the problem which has been given to us. So we have to solve by using we have to solve this problem. So here, how to analyze this problem? The first point what we have is a pentagonal lamina of edges 25 mm. So he has given the side of the lamina. He says it is resting on one of its corners. So one of the corners on HP. Such that the perpendicular bisector means what? So next condition is the perpendicular bisector. Perpendicular bisector is the one which is joining between the corner to the opposite side. The corner to the midpoint of the opposite side. So the corner to the midpoint of opposite side. For example, if you are considering a pentagon here, which is placed on all the corners on HP, such that one of the edges is perpendicular to VP. Whether the corner is resting on HP or the edge resting on HP, always in pentagon you will going to get the perpendicular to VP itself. That is basically because one end of the line is a corner and the opposite end will always be an edge in a pentagon. Similarly, in a triangle also we have one side is a corner and the opposite side will always be an edge. So since it is joining between the corner to the opposite side, the midpoint of the opposite side. So how many sides we have? We have 5 sides. So we should be able to get 5 perpendicular bisector. Out of those 5 perpendicular bisector, which perpendicular bisector I need to consider? We have to consider a perpendicular bisector which should be parallel to VP. Why? See, basically because in which the lamina is given here. The lamina S is inclined at 30 degrees to HP. So he has given the true inclination. So true inclination 30 degrees to HP is given. So since the true inclination is given, so naturally inclination with respect to HP will be seen in vertical plane. So where is the vertical plane? The vertical plane is in the front view. So that means in the front view that perpendicular bisector has to be in total. When I will going to get that? When that perpendicular bisector is parallel to VP. If it is parallel to VP, then only I can see the true length in vertical plane according to our projections of straight line. So since AM is parallel to VP, so I am getting the true length. So that is the reason why we must consider only between the corner to the opposite edge when it is in parallel. So this will be A to M will going to be the perpendicular bisector which will be parallel to VP, because when you look from the top view, the 2 points of A and M are equidistant from the vertical plane. So that is the reason why it will be parallel. So hence you will going to get the true length. So this is the 3D analysis, and here this is the one which we are doing in the 2 dimension. And basically we have not shown the shade here because that I will not be able to see the perpendicular bisector if I shade. That is the reason why we have removed the shade here, as not in the case of the other problems wherein we have shaded everything. So even though we have not shaded, that means this is the surface. Since it is a surface, the surface is parallel to HP and perpendicular to VP. So that is the reason why in VP we are getting a line. In the next position, if you see, is placed one of its corners on HP such that the perpendicular bisector of the edge passing through the corner on which the lamina rests is inclined at 30 degrees to HP. Now initially it is parallel to HP. So since it is resting on one of its corners, so I am resting on A dash as the one of the corners. So rotated such that it will be inclined at 30 degrees to HP. So you draw a line at an angle of 30 degrees and measure the length from A dash to C dash. With A dash as center, cut an arc on this. Then with A dash as center, measure the length between A dash to B dash by using compass. With A dash as center, cut an arc on that 30 degree line. So you are going to get the point. B dash and E dash. So you're going to get C dash, D dash, M dash. So you draw this line because that is the front view which is inclined at which is the perpendicular bisector, which is that A dash M dash is inclined at 30 degrees to HP. So you are going to get the inclination. Once you get the inclination, once you draw the front view, to this you need to write the top view. So I am looking from the top view. So draw a vertical projector from A dash and draw a horizontal projector from A to get this point. Similarly, draw a vertical projector from B dash and draw a horizontal projector from B to get B. Similarly, draw a horizontal projector from E to get this point. Similarly, draw a vertical projector from C dash and D dash and M dash and draw a horizontal projector from C to get this point, from M to get this point, and from D to get this point. Since the perpendicular bisector is inclined to HP, so I am getting the apparent length here. Since it is parallel to a perpendicular bisector is parallel to VP, I am getting the true length here. So now the surface is inclined to HP, but still the surface is perpendicular to VP. You can see here this entire surface is perpendicular, that is at 90 degrees to VP. You can see this line which is 90 degrees to this vertical line. So obviously that will be a line still. Then we will go to the next question. So the perpendicular bisector we are passing through the corner on which the lamina rests is 45 degrees to VP. So which is the perpendicular bisector on which the lamina rests, which is A dash and this M dash. This A dash and M dash is inclined to VP at 45 degrees, he mentions. So here also he has given the true inclination. But here this perpendicular bisector, once it is inclined to HP, so I am getting the true apparent length here. Now the inclination given is true inclination. So you can see here, first what we need to draw from through the point, because A dash has to be on the corner which should never change. So through this point, since he has given the true inclination, so you draw a true inclination line of 45 degrees. Then measure the true length of that particular perpendicular bisector. So we need to understand where I will be able to find out the true length. Now because now the surface is inclined, so the perpendicular bisector is inclined. So we are getting the apparent length here. But where we are going to get the true length? You can see here the two endpoints of the perpendicular bisector AM is parallel to VP, so I am getting the true length here. 1 point. Similarly, the true length of the perpendicular bisector which is A dash M dash is parallel to HP, I am also getting the true length here. Similarly, the perpendicular bisector AM is parallel to VP, so I am getting the true length here also. So you can take either this or this or this. Since we are writing in the top view, to measure the length from A to M, we consider any point on that 45 degree line and cut an arc on this to get this point and draw a locus. Now this length is the apparent length because this is the one which I need to transfer here. So since I don't know where is the inclination, so I measure the length from A to M. With same point as center, cut an arc on this by using the compass. So you can see here 33.3169 is here. Similarly 33.3169 is here also. Then once you get that, then from this point, now we got the point M and we have a line now. So through M you draw a perpendicular to AM. So from M, by using the protractor, you measure a 90 degree to this inclined line and draw a perpendicular line. Through M, you measure the length of M to D and M to C, both will going to be equal. With M as center, cut an arc on this line and cut an arc on this line by using the compass. Then measure the length from M to this point. From M, you cut an arc on this. So you get this point. So now you can see here, through this point, you have a line which is perpendicular to this. So you have a line now which is inclined here. So you have got this point. By using the protractor, you measure an angle of 90 degree with respect to this line and draw a perpendicular line to this line. Since these two are divided equally, measure the length from this point to E From this point you cut it on this, and also you cut it on this side. So you're going to get A, B, C, D, E and E. Join A to B, B to C, CD is already joined, D to E and U to K to complete the pentagon. So this is how we will be constructing the third position top view. Once you get the third position top view, now you have changed this. Now we need to write the front view. So A dash is on XY line. From A you draw a vertical projector to get the point A dash. Similarly, draw a horizontal projector from B dash and E dash, and from B you draw a vertical projector to intersect at B dash, and similarly from E draw a vertical projector to intersect at A dash. Similarly, you draw a vertical projector from C and also from D, and from C dash D dash you draw a horizontal projector to get the point D dash, C dash and D dash. If you want, you can draw a point from M through this to get the point M dash. It need not to be shown. Only this M reference is required only for transferring the dimensions. So how do I know that my problem is now? This is how we will be able to complete this particular solution. So to have the one more whether the problem what I have done is right or wrong, but still you can see a pentagonal lamina of 25 mm is resting on one of its corners HP. The perpendicular bisector of the corner passing through the corner is inclined at 30 degrees to HP, and also which is inclined at 45 degrees to BP. And even in the final position you can see that the pentagon is on the corner. This is how we will be able to analyze the sketch. Thank you.